This is my comprehensive recommendations for using the various types of encryption in order to completely secure a database. The reason why current database security methodologies are insufficient are that database administrators will get access to it, and it'll be unencrypted from the disk, and they can see inside of it. So anybody who can manage the database will have inappropriate access. They'll violate least privilege access to the data. And it's a regular database is going to be, for that reason and a few other reasons, going to be entirely insufficient to meet the security metrics that we should be expecting out of our data. So about every aspect of encryption will be used, including asymmetric encryption, symmetric encryption, one-way digests, password-based encryption. That's all. And one more trick is combining multiple people's passwords into a compound encryption key. You'll use asymmetric encryption so that you have a write key and a read key. And that'll give us, we can use those for access control listing, where some people will get only a read key and others will get a write and a read key. Symmetric, you leverage it to have rapid encryption and decryption of data. Asymmetric is too slow for the data itself, but it can be used to encrypt parts of it such that you can effect read and write control on it. And digests are even faster if you want to do compares. You can reduce a digest to an amount that to a compare that can be done in one CPU instruction. And you use password-based because passwords are the only encryption key that can be entirely undisclosed from public view, basically. Any other type of encryption key is going to be saved somewhere. So what you'll do is allow these encryption keys to a person who presents a password. They will encrypt them and save the encrypted version in another table somewhere, and probably use groups. So a member of a group will bring his or her password. We'll get a suite of encryption keys, and we'll password-based encrypt them, and they will be saved in the principal's data. In order to be able to do that, you'll have one master key that will have access to all of the groups and the passwords, but in order to effect utmost in security, you may use multiple members of a group, somewhat of a quorum, and each of them will have to present a portion of the entire password encryption key. So nothing can happen to the database until each of the members are present. So the structure of the database will look something like this. You'll have a row. You use an auto-incrementing ID to have a sensical counter for the data. It'll be increment deterministically, so you can, at quick glance, you can tell whether a row has been skipped, removed, etc. You'll have a group key just to know to which group of passwords this row will belong to. That'll help for something that I'll explain in a minute. You will need a key that is a primary key that is good for row searching. And that will be encrypted in the row, but it'll go into an index that I'll explain in a minute. Then you will, the symmetric key will be used to encrypt any column data, what you'd call data. And then for the whole row, in order to ensure it has not been compromised, you'll take a signature of it, which is a one-way password of all the data in the row. And then to another assurance that no rows have been compromised, you'll take a summary signature of all rows up until that point. So the way you effect access control and find rows that are pertinent to a person who has access to some rows but not all, reading some and writing but not all, is you'll construct an index using the access control or asymmetric keys and the search key that is pertinent to the table in question. So basically have a balanced tree. You'll do a short digest of the search key, primary search key, and create a balanced tree of it. It'll be very easy to traverse until you find a locale where the key matches. And since you'll crunch it down to a very small digest, say 64 bits that can be compared in one instruction, you'll probably have collisions, so you'll keep a bucket, and in that bucket you'll keep an asymmetric encryption of the entire key. So that can only be inserted with a write version of the asymmetric key and can be read with the read version. And when you find the line, when you traverse this bucket, you'll find the line, and then you can also reverse encrypt, unencrypt the row ID that was put in there via auto increment, and you'll get your row back out. And then when you get your row back out, you can use the symmetric key to unencrypt the data. So for this index tree, even if you could add sneak a row into the database, you couldn't add it to the index tree without the proper write asymmetric key. So you would have to belong to the group, and you'll have had the right password to unencrypt the write asymmetric key. That's how to do it.